So you have a science fair project coming up. My purpose of this video is to give you a little guidance of what not to do and some things that you definitely need to do to help make your science fair project successful. In judging science fairs, sometimes we see things that we see all the time that's not really a science fair project, it's more of a demonstration. And then we see things that students that really knock it out of the park with some of their projects. So I wanted to give you some guidance of what not to do and what to do. So first, what not to do. Um, don't do vinegar and baking soda. We all know what happens when you mix vinegar and baking soda. It's a demo, it's gonna fizz, it's gonna produce bubbles, it's producing a gas. We know what happens with vinegar and baking soda. Um, so that's not going to do well in a science fair. We all know that strawberry has DNA. Those are demonstrations. We're not experimenting to see if it has DNA or not. We know it has DNA because that's a demo that you've probably done in class. We know an apple will turn brown if we leave it out. We know those things. Those aren't really things that we're experimenting to see. Try not to pick things that people are familiar with. Pick things that matter to you. Pick topics that matter to you, something you truly want to run an experiment on, not a demonstration. Something that you are really experimenting to see maybe which product is best or which brand is best or what method of something works the best. I'm going to try not to give too many specific examples because I don't want to give away a project for you to use. I want you to come up with something on your own. But do something that is truly an investigation. A lot of you have beautiful display boards when we go and judge these science fairs, and they look awesome, and we can tell you put a lot of time into them. But you have copied and pasted information from the internet on that display board. This science fair project should be your information. It should be research that you've done. It should be what you've learned. It should be your data. It should not be copied and pasted from the internet and slapped on a poster. Make it yours, make it unique. No copy and paste, no copyright infringement. Do not use other people's data. Take your own data. Don't go to the internet and find some data that somebody else has used. And take a picture of somebody's graph, and then especially if you don't know what the variables mean and you're just putting a picture of a graph on the poster board, just make sure it's your data and it's your work and you're not copying somebody else, and you are doing your best to put your work out there and actually run a true experiment with your data. I don't care if the board's messy if it's your data. I would rather it be a true science experiment that you have done if I'm judging this. So just do your own experiment, not a science demo. No copy and pasting. That's copyright infringement anyway. And don't use other people's data. Use your data, okay? So now I'm going to give you a real life example of how I apply the scientific method in my life. That's why we're on my property with my garden in the background, because this is one place where I really did use scientific method because it mattered to me. And so I want you to pick something that matters to you. And I'm going to take you step by step through the scientific method so maybe you can get an idea of how you can apply it to your life and find something that matters to you. And side note, because we are out here, the phone is propped on the chicken pen. So if you hear the chickens, and that's what you hear, you might even see a dog running back and forth from time to time. All right, but step one, you need to have a problem. What are you investigating? And be very specific. Don't be broad in your problem. Be very specific in your problem because that helps it to be more testable. So my problem that I had is we grew a type of tomato called Better Boy tomatoes, and we did not have much luck one summer when we grew these tomatoes. So a neighbor suggested that we try the variety of a Parks Whopper tomato. Some of you may have heard of that. And so I wanted to see which one was better. So here is my question for my problem. Will Better Boy tomatoes or Parks Whopper tomatoes produce more fruit in my garden? I was very specific with my types of tomatoes. I was specific of where it was in my garden. I really probably could have been more specific as to which quadrant of my garden I was putting it in. But notice I didn't ask which tomato is best, because there's lots of varieties of tomatoes. I named specifically which tomatoes that I'm comparing in my experiment. So be very specific with your problem, and very specific in the question that you're asking. Step 2, the research. Now, I probably could have done more research with this. This is what my research consisted of. My grandfather lived across the road when he was alive, and he was one of the best tomato farmers around. And he used that for part of his income, and he sold tomatoes, and people they still talk about how good his tomatoes were, and he used Better Boy tomatoes. So, of course, if my grandfather used Better Boy, I'm going to use Better Boy, right? Because my grandfather did, so that's got to be the best. But we grew, like I said, we grew those one year, and we didn't have much luck, and a neighbor suggested that we try the Parks Whopper tomatoes. They had luck with those. So we decided one summer that we were going to grow both types of tomatoes. You can hear the chickens singing in the background, I'm sorry. But we're going to grow both types of tomatoes to see which one was best. And we grew equal amounts of each plant. And so my hypothesis was, and I used an if, then, because statement. I like that format. If I grow Better Boy and Parks Whopper tomatoes, then Better Boy tomatoes will produce more fruit because they produced well for my grandfather. Now, granted, that was not based on scientific research, and I probably should have done more scientific research, but in my head, that was my reasoning. So I said what I think will happen. If I do this, then this will happen, and I told why I think it will happen. You need to make your hypothesis before you run your experiment, because it's okay if it's wrong. That's science. We're discovering. We are proving things wrong. We're proving things right. It's okay if your hypothesis is wrong, okay? You're not supposed to make your hypothesis after you run the experiment. That is for before the experiment. So, step 3, you run the experiment. So if I'm judging your science fair project, I want to see your procedure written out. I want to see what you did. I want to be able to look at it and go, I could repeat that if I wanted to try this experiment. If I wanted to test it, it needs to be repeatable. So you need to have the steps written out so we can see exactly what you did. We can tell that you planned this, that this is your experiment. The more details you can provide, the better. List your materials. What materials did you use? List your variables. Now, there's a word sometimes that we forget is important in science fair projects. But your variables, you should have an independent variable and a dependent variable. So independent is going to be what you can control. Okay, that's going to be on the x-axis on your graph. We'll get to those later. But your independent is what you control. So my independent variable in my tomato experiment was the species of tomatoes that I used. Your dependent variable is what depends on your choice of the independent variable. So my dependent variable was the number of fruit that were produced by each type of tomato. So independent was which type of tomato. My dependent was how many fruit were produced. That's measurable. That's something that I can count, I can report. The things that were constant for each plant is they were in the same soil. They were getting the same amount of water, the same amount of sunlight, same pesticides, the same care. So that was constant for all the tomato plants. All right, so step 4, collect your data. Actual data, not data that you go online and see that somebody else did. Your data. You run the experiment, you take your data. Whether it's you've timed something, you're measuring something, you're making observations, you're counting something, like in this case, I'd be counting tomatoes. Whatever it is, take your own data and report it. Whether it's what your hypothesis said or not. And then display your data. So how do you need to display your data? Tables and graphs. So with my count of tomatoes, if I were doing the science fair project on that, I could have done a table of Parks Whopper, put a count beside it, and Better Boy tomatoes and put a count beside it. I could have even gotten more detailed and put how many were produced in June and how many were produced in July. So you can get very detailed with that, and then report it in a graph. Show me a graph that shows your findings, because graphs are a really quick way to look at things and see the results of your data, and really easy for other people to see, and it's easy for you to communicate your results to people using that graph. So in step 6, form your conclusion. Was your hypothesis correct? Well, for me, my hypothesis was wrong. The Better Boys did not produce the most. The Park Whoppers produced the most. So my conclusion was, because Park Whoppers produced the most tomatoes and my hypothesis was wrong, and that was okay that it was wrong. Now we don't even grow Better Boy tomatoes in the garden. We grow our Parks Whopper tomatoes, and we get the most produce out of those, and we're able to put those up and enjoy during the summer. And also report in your conclusion, what would you change about your experiment? Is there anything you would change? Is there anything you would do different? If there's something you would change and you think to do different, it would make your experiment better, do it again and report that. Report, okay, so I redid my experiment. That's science. That is practicing science, is experimenting and redoing tests and making your tests better and making them more consistent. And how can you use this information, and how is it applicable to the people around you? So those are just some things to consider. I'm sure I missed something. I just wanted to hit the high points of what you need in a science fair project, and hopefully we can improve the quality of science fair projects across the region. And good luck in your science fair.